Okay, we're going to fill in some notes here on lesson 1-7 here. It talks about constructions. We're not going to actually do constructions, so we're not going to worry about that, but there are some major definitions that we're going to see in section 1-7. First one up is perpendicular lines. This is where two lines intersect at 90 degrees. Okay, you might have many two lines like my pens here that intersect, but when they intersect perfectly at 90 degrees, we would call those perpendicular lines. And you would always denote the 90 degrees with this box here. And in this picture, you would say line AB and line CD, and I want to show the symbol for perpendicular, are perpendicular. What the symbol for perpendicular looks like, kind of like an upside down T. But they're indicating that this is perpendicular right there. So when you see that, that means perpendicular. The two lines, not only do they intersect, but at 90 degrees. The next one here is perpendicular bisector. Well, perpendicular we just talked about are two lines that form 90 degrees. Bisector is basically, bi means two, and it's going to split it into two equal halves. So, perpendicular bisector will form 90 degrees through the midpoint. That's kind of different there, but let's just show a segment, not a line that goes on forever, but just a segment here. We'll call it segment AB. Now, a perpendicular bisector to that line will be this red one here. It is not only going to be 90 degrees for perpendicular, it's also going to be right down the middle. So there's the 90 degrees indicating that that's perpendicular. And then the portion on the left and the portion on the right are equal, so there's a tick mark here and a tick mark here. And that's where the bisect comes into play. So this right here is considered the perpendicular bisector. 90 degrees and splits segment AB perfectly in half. Okay, this next one is an angle bisector. We just mentioned what a bisector is, something that splits something in two. Well, in this case, we're going to split an angle in two. So you have this original angle here, JKL, and in this picture, NK, is the angle bisector because it splits that yellow angle in half. So you can see these little tick marks for things being equal, equal, equal. So maybe if this was 100 degrees, now it's 50 degrees, 50 degrees. But it basically splits an angle in half, an angle bisector. Okay, let's do number 1 and number 2. Number 1, if M, the measurement of angle JKN is 50, find the measurement of KNL and the measurement of JKL. Then it also says KN is the bisects line JKL. That's going to be critical there. KN, this line here in the picture, K to N, is the bisector of this yellow angle, JKL. So that means it's split half and half. First of all, it says angle JKN is 50, so this is 50. And because this is the bisector, this tick mark, this also has to be 50 degrees. So when they ask you what's the measurement of NKL, that's got to be 50 degrees. What's the measurement of this big yellow angle JKL? Well, that is 50 plus 50, 100 degrees. All right, let's move on to the last problem for the day. Let's read it first. It says WR bisects, so that's the angle bisector of angle AWB. So this yellow angle there, which of course means it splits it in half. Measurement of AWR is x. They already put it in the picture. BWR is 4x minus 48. Find how big AWB is. Now again, this line here in the middle is the angle bisector. It says it's bisect, so that means this top portion is equal to this bottom portion. And that is going to be our equation. We're going to solve for x. We're going to say this top portion, which is just x, is equal to the bottom angle, 7x minus 48. We're going to solve for x. And then once we solve for x, we would plug it into the picture, and you can figure out the angle in yellow, AWB. Okay, but let's first solve for x by realizing equal angles. I'm going to add 48 over here, and I'll minus x over this direction. This is 48, the x's go away. This is 3x, divide by 3, 16, when I divide by 3. So that means this is 16 degrees, and if I put 16 here, multiply by 4, and minus 48, this will also be 16 degrees. So the measurement of angle AWB is 16 plus 16, 32 degrees.